So hey guys, I'm Sev. I'm the president of SAE for this year, and that's William. He is a vice president. We are the Society of Automotive Engineers. So we are a collegiate chapter of SAE International, and yeah, we participate in the collegiate design series. Yeah, Will, you can go ahead.
Oh wow, okay, already? All right, cool. So like Sev said, I'm the vice president of the society, and I joined SAE back during these presentations when I had Frosh, maybe almost, yeah, 3 years ago now. And literally a week before school started, I was already like a member of the Baja team. So yeah, I've been on Baja for the last 3 years, and I was a lead on the team, and now I'm also a member of the SAE Council. So I've been around SAE. I know a lot about it, and I'm going to be presenting to you today just quickly who we are, what we do, and what the design cycle is all about and how it works. And then once I pass it off to the other teams, they're going to get a bit more in depth of like specifics for their teams, because all of the teams that we have, they run differently. I'm going to get into which teams we have later on. So SAE International, so the Society of Automotive Engineers, they're a standards industry basically, and they write standards for anything you can imagine. So if you take a screw or a bolt, there's an SAE standard for it, and it's a set of documentation stating different design specifications for those bolts, let's say. And they also host events year-round, internationally, all the way around the world, for the automotive industry. So anything automotive, even there's aerospace, they're in it. And they also have something called the CDS, which is the Collegiate Design Series, and that's what Concordia SAE is a part of. So we're a student chapter of the society, and we participate in CDS events. So we'll build cars or airplanes, and then we'll go to these events and compete against hundreds of other universities around the world. Right now, our society has about 50 members plus. It's hard to keep track because we're always getting new rookies. We're always, so some people are always leaving to work on capstone projects. Like it's constantly fluctuating. But right now, even with quarantine and not being able to go into school, we have a decent amount of members, and we're always looking for new people. So it doesn't matter what discipline of engineering you're in. You don't even have to be in engineering. You could be in marketing. You could be a JMSB student, and you can still join, because Concordia SAE is, it's not just like, we're not just building cars, we're running a business really. So there's a whole aspect where we have to acquire sponsorship to make sure that we can build what we need. We can get money, machining time, anything you can imagine. So it's important that we have a wide variety of students. Before getting into the teams, I'm just going to briefly go over what the engineering cycle is, the design cycle, because it's very, very important, and it's going to be used in every single one of your classes throughout your entire degree. And then once you graduate, it's used in any type of product you can imagine in industry. So even like a pencil like this, it's gone through the design cycle. So you can imagine that from a simple product like that, or even a piece of paper, to an iPhone or a car, it's gone through the design cycle many, many times. The basic steps of the design cycle are defining a problem, identifying a need, designing. So the design part would include like mock-ups, drawings, measurements, stuff like that, brainstorming. And then once you have your initial final design, yes, initial final, I know that doesn't sound right, but that's the truth. That's what it is, because you're going to be redesigning it eventually. You can start testing and validating that design. So you could build it, you can test it on FEA analysis. So FEA is finite element analysis. Basically, you would put it into a software that uses mathematical calculations, statistics, numerical methods to calculate how your object is going to react to a specific force, let's say. And then once you have all of that information, you can improve your design and then repeat the whole process over and over and over again. So you see a pencil today, it's gone through that 100 times, and it's going to go through it 100 more times. They're going to find better ways to make it more ergonomically comfortable. They're going to find a better lead, a better eraser, a better wood, a more eco-friendly wood, let's say. And yeah, that's the basics for the engineering cycle. And we use this every single day at Concordia SAE. So we design, we manufacture, we test, we redesign, and then we compete. And sometimes you also have to redesign because things will break all the time and nothing ever goes the way you're planning it to go. And that's why SAE is so much fun, because you're always working on a solution. So you'll find a problem, and then you'll fix that problem, but then you'll make two more problems because you didn't think of something else. And then you have to fix those problems, and it's constantly working like that. So right now we have 4 teams. We have a formula team, which is consisting of an electric car and a combustion car. We have a Baja team, which makes off-road vehicles, like the one in the left picture there. We have an aero design team that makes a few different types of airplanes, remote controlled airplanes. And then we also have an aero connect team, which is quite new. This is their 2nd year, and they work on a like a design basis. So every year they introduce, the SAE International introduces a new design problem, and then Aero Connect has to prepare a report, or like a bid, let's say, to submit to SAE International to try and win the competition. Now I'm going to go into what all the teams are working on overall for the new year, so you could see what's to come for them. It's very exciting. Even though we're all working from home, there's a lot of stuff that we're trying to do, and we're trying to have a lot of really cool projects this year. So for example, Aero's working on a black box, and that's going to collect telemetry, and like it's going to be for data acquisition mostly, because they haven't had that before, so they don't really know what's actually going on with all the instrumentation on their plane while it's in flight. And so it's very difficult to improve on a design if you don't have any data. So this black box is going to be used to collect all of that data. And also they're planning on, every year they redesign the plane completely. So this year they're building a new type of plane, and they're planning on testing last year's plane to collect more data. So normally, because Montreal is such a weird weather place, like it's not common to go out and actually test here because the weather can be really bad. And normally they only fly it once they get to competition in Florida or wherever they're having competition. And this year they're actually planning on going out and testing it at some RC airfield. So that's a pretty cool challenge for them, since they've never really done it before. And this year they're building 2 planes, a regular class plane and an advanced class plane. So I don't really know the difference, but later on the coordinator for Aero is going to talk about it, and he'll be able to explain a bit more what the 2 different types of planes are. So now what's new with Baja? Oh, that's a pretty picture. Sorry, I haven't seen that picture before. I really like it. Something that's really cool is last year we had a capstone team. So capstone is the final year project, in case you didn't know, in engineering. It lasts 2 semesters, and it's a full-on design project. So you pick a project, and then you go from design to conception, like you go from conception to design to manufacturing to testing to validation and all of this stuff, and then you write a big, huge report, and that's the end of your engineering degree normally. So last year, the Baja team had a whole bunch of 4th-year engineering students who wanted to do an electronic CVT. So the CVT is a continuous variable transmission, and so like normally a car would have an automatic transmission or a manual transmission. This is just another type of automatic transmission, and it uses a belt and pulleys. So now instead of it being operated with mechanical weights and springs, it's operated completely electronically with code. So it's a really interesting project, and it hasn't been used on our car yet, because once we were about to start testing it, they didn't let us into the labs anymore because of coronavirus. So this year we're going to be focusing on integrating that into our car. And right now there's only 3 teams in the world that have an electronic CVT. So we're one of the very few teams that have it. So it's a very exciting project, actually. And another really cool thing that no other schools are doing right now is the steering wheel for Baja is going to have paddle shifters, so we can control the electronic CVT a little bit more. And yeah, no Baja teams right now have a paddle shifter on their steering wheel. So that's really, really cool. And another big project that we're working on this is a capstone project. Actually, this year, it's my capstone project. We're working on a 4-wheel drive system for the car. So right now, the car is just rear-wheel drive, and we're going to be making it 4-wheel drive because the competition rules are changing in a year from now. So that's going to be a big project, and it requires a lot of integration. And that's also why we're working on a new frame design and a new suspension design, because we have to make sure everything's going to fit together properly. So those are the big projects for Baja this year. Formula this year has a lot going on because we just recently decided that we're going to put a lot of effort into making the electric car go to a competition. So the electric team has been around for a while now, but we haven't really had a chance to compete properly with a fully working vehicle. So now we finally have a bit more resources in terms of people to get the car together and finish the design cycle on it and have it go to a competition and compete. So that's very exciting. We don't know yet what's happening with competitions this year, but hopefully we'll have a better idea soon. And the electric car is also focusing, they're putting a lot of emphasis on testing their battery packs because the batteries in operation get really, really hot. So they have to test their cooling system to make sure that the car is not going to explode, because that would not be good. Finally, on the combustion side of things, so the combustion car, they're working on a new aero mounting. So last year, I believe, there was a capstone project. What you'll notice is SAE hosts a lot of capstone projects. So if you're a member of SAE for a long time, it's really, really useful for later on in your degree. So yeah, there was a new aero package capstone to improve the performance of the car. And now they're working on mounting it onto the car. And they're also working on an electronic clutch. So before I pass it on to the next segment, let's call it, this is typically what being an SAE member will look like. So being students at university and not being in a society like Space Concordia or IEEE or Concrete Toboggan or any of them, you won't necessarily get access to specific labs. Whereas if you are a member, you do get access to these high quality, really cool labs like the EDMLs, where you can do some manufacturing. And what's great is this allows us to work on some pretty insane projects that normally you don't get to work on. Like the value of our cars are in the hundreds of thousands of dollars, all of them. So it's really cool to work on all of these projects, and it's super important to be able to apply the knowledge that we're learning from the class to an actual project to actually understand what you're working on. And another thing is that you learn things that you wouldn't learn in a classroom too. So when I started SAE, I knew nothing about cars, and now and then I ended up being a lead like 2 years later for the transmission system on the Baja. So you start learning, and everybody's there to teach, and it's really, really cool. And you get to make some really great friends. And at competitions, you get to network with industry professionals, and it's even possible to get jobs at competitions. We've had several students like talk to an engineer from Tesla at a formula competition and get a job at Tesla the next summer, let's say. So yeah, that's the end of my part of the presentation, and now I'll pass it on to Aero.
Wait, before you do, there's one thing that I wanted to show. Will, can you stop sharing this second?
Yeah.
Thanks. I swear COVID is making all of these IT problems even worse. Yep. There you go.